Welcome back, guys. So we've been asked to evaluate this problem right here. In my previous video, we worked a similar problem, and I told you the moment you see a square root sign, you try to substitute to get rid of the square root if you can. That is the first step in solving problems with square root signs and stuff like that. So in this case, we're going to apply the same idea. So I'm going to substitute to get rid of the square root sign first before I even, use any sort of integration skills. So we have this guy and that guy there to be the same. So what I'm going to do is I will let my x to be equal to u squared, so that when I substitute, the square will cancel the square root. So in this case, I will let u squared to be equal to x. Then, if I differentiate this side and that side, I get 2u du is equal to dx. Now I can go ahead and do my substitution. So it will be equal to u squared in place of x, e to the power of u squared, all under the square root. And our dx is this guy right here. So you have times 2u du. We can factor out our 2. So we have 2 out here. Then this guy, let me set the different thing here. Then the 2 here will cancel the square root sign. This guy will also do the same. So we have u e to the u multiplied by u du. So at this point, we are just going to multiply this guy by that guy and get u squared. So we're going to have 2u squared e to the u du. So at this point, we've got into this step. What you should notice we have two things multiplying. We have the u squared multiplied by the e to the u. So the best thing to come into your mind is integration by parts is going to work on this guy right here. So we're going to try integration by parts. So remember, integration by parts, we will let our u be equal to something, but here we have already used u, so we're going to use a different letter for it. So we're going to let a. I will let my a. I'll let my a. I'll let my a be equal to u squared. Therefore, dA will be equal to u du. I will let my dv to be equal to eu du. Therefore, my v will be equal to eu divided by the differential of u, which is basically 1, so like that. Then, if you remember our integration by parts, we go this way, then we go that way. So we're gonna have u squared multiplied by e to the u minus that, then this times that. So we bring our 2 out, then we have u e u du. So at this point, we are done with this part of the problem. We solved this part of the problem because it doesn't have an integral sign. So what we're going to do is we are left with this part, and we're going to bring that one down here and deal with it. Now we're going to repeat the problem. We are going to leave our 2 right here, but we will later come back for it. So in this case, we also have another 2 things being multiplied. So the best thing that should come into our mind is integration by part should work here too. So again, we're going to use a letter like A because we already have U in the question. So we will let A be equal to U, the A to be equal to the U. Let the V to be equal to E to the U, the U. V is equal to E to the U. Now, we do the same thing as we did in our previous step. So we have multiply this by that, we get U times E to the U minus the differential of this and that, which is basically E to the U du. So this part of the problem is also solved. So what we're gonna do is we're gonna solve this part, and this part will literally give us E to the U. So now let's put everything that we've done here together. You first have this. We first have this. We started with that guy here, that is the 2 being multiplied by the whole function. We started with that guy here, that is the 2 being multiplied by the whole of this. Then we let our A be equal to that, then we came here. So we also left a 2 at this point right here, so we shouldn't forget about that. So what we're gonna do is we're gonna bring everything down together. So we're gonna have that first 2 that we had. That's gonna be 2 out, and that is gonna multiply the whole of this guy here. So we're gonna have 2 out inside a big bracket, U to square it E to the U minus this guy. See, but this guy has also been broken down into this guy and that guy. So all we're gonna do is we're gonna write another 2, that is this 2, then we're gonna put into bracket this guy and that guy. Minus EU plus C. So right now, what we're gonna do is we've actually solved the problem, but we need to substitute for U. We know from the top here that U squared is equal to X. So wherever you see U squared, you put X, and wherever you see U, you put S to the half. So we have this guy right here. We have to use square, so we put x multiplied by e. We have u, so that will give us square root of x minus 2. We have u here, so we put root of x multiplied by e to the root of x minus e to the root of x plus c. So we can go ahead and go one more further and do simplify this, but this is actually the answer, but we can go ahead and do a little more simplification. So at this point we will see that we have e to the power root of x here, we have the same thing here, and we have the same thing there. So we can take it out. So we can take it out and put it here as 2 multiplied by e to the root of x. Then we have a big bracket here, x minus 2 to bracket root of x minus 1 plus c. We can go ahead and open this bracket up. We have 2 to the x minus 2 root x plus 2 plus c. So boom, you solved the problem. It was a problem which involved multiple steps of integration by parts and use substitution, but it wasn't all that hard. So go ahead and keep practicing. If you have any question, just leave me a comment and I will see you in my next video. Thank you.